Well, good morning or good afternoon or good evening, depending upon what time you are watching this. So today, what I wanted to do was go through how do we write the equation of a non-shifted ellipse. Now, again, just like we talked about yesterday, all of our ellipses today are going to have the center is going to be located at 0, 0. So just so you know, that means the h and the k values will be zeros. Also, remember, yesterday we talked about the form. We had x squared over a squared plus y squared over b squared equals 1. Now, if the a squared is larger, remember the a squared is always the larger of the two values, and if it's underneath the x squared, it goes left and right. And then the other one was if you had x squared over b squared, and then you had y squared over the a squared was 1, that meant that it was stretched up and down. And that kind of is what's going to be our little go-to as we go through these guys for the rest of the way through. So, also, you had A. A was the distance from the vertex, center to the vertex. Your B value was the distance from the center to the, what we call the covertex. And then the C value is the center to the foci, or focus, however you want to call it. I just call it focus because we're talking about just one of them. Now, with an ellipse, I kind of alluded to this earlier, where it says that since this is a plus sign between the two, to figure out the C value, the C squared is always going to be A squared minus B squared. So then you would just solve it out and go that route. So today, let's start with an example. Let's say we have our vertex located at 0 and 6, and our covertex located at -2 and 0. So when we start these problems, first of all, we have to figure out which of the two formats are we in, which way is this picture and this diagram shifted, or stretched, not shifted. So what I always like to do is rough sketch it. Vertex at 0 and 6, so that means my vertex went up. 1, 2, 3, 4, 5, 6. So right away, my vertex is up. That means it's being stretched up and down. So if I have one vertex, that means your A value is 6, which therefore means that my A squared value is 36. So if I have an A value of 6 went up this way, my center is at 0, 0, that means there has to be another one at -6. Covertex at -2, which means there has to be one at +2. So your B value was -2, or in this case, remember distance is always positive, so you can just call it 2 because it just went to the left. So your B squared was 4. So now we use to figure out our C squared. Our C squared was A squared minus B squared. And honestly, do we even need to find the C squared? Is there a C in this formula? There isn't. All we needed to know was the B squared and the A squared. So we know that it's going to be x squared plus a y squared equaling 1. Since this is stretched vertically, that means that the A squared term goes underneath the y, and the B squared goes underneath the x. And that's what that would look like. Here, we didn't need to worry about the C value because we didn't have to actually locate it, because all I'm asking you guys to do today is just write out the equation. Okay? All right, let's look at another one. So let's try another one. Let's say we have a vertex located at 0 and 7, and a focus at 0 and 3. All right. Everything's centered at the origin. So 0, 7. So it's up there again. So right away, you know it's stretched vertically. You also know that your A value is 7, because that's always the distance from the center to the vertex. That means your A squared is 49. The focus is at 0 and 3. So that means you know that your C value is 3, which therefore means that your C squared value is 9. Now this is the case where we do have to figure out what b squared is, because we don't know. So we know that c squared has to equal a squared minus b squared. Well, if c squared is 9, a squared is 49. 49 minus what is 9? Well, it has to be 40. So we have x squared plus y squared. We know it's over equals 1. It's stretched vertically, which means the a squared value has to go underneath the y value. And we figured out our b squared value is 40. We don't have to find what the b value is. We don't need to worry about it. I'm not asking you guys to graph it or anything. All we need to know is that the b squared is exactly 40. Let's try one more with the other kind of scenario that we can come across. Let's say we have a covertex. A lot of times I just write it as covert. And a covertex at 0 and negative root 3. And a focus at negative 1 and 0. So once again, I like to start these problems by rough sketching. Covertex, 0, negative 3. Well, 0, negative 3. Negative 3 is somewhere, negative root 3, excuse me. That is, excuse me. Square root of 3 is more than the square root of 1, but it's less than the square root of 4. So it has to be somewhere in here-ish. A little bit less than 2. So your covertex is a b value. So if your b value is the square root of 3, remember, distance, because you can go up or down. So if your covertex is going up and down, that means this guy has to be stretched left and right. So this means it has to go this way. So your b is root 3, so your b squared is 3. Your focus is at negative 1. If your focus is at negative 1, remember the vertex always opens up to your focus, so it has to be stretched this way. So that means that this distance is the c value is 1. So remember, I'm disregarding the negative here because distance, it's either 1 here or it's 1 there. It's still the same value. So to figure out what c squared is, this is real tough. Feeney, I think even you can get this one. Nice. All right. So c squared has to be a squared minus b squared. Well, 1 is something minus 3. I wonder if I took 3 away from some number to get 1. Could it be 4? So now we know that our a squared is 4. Our b squared is 3. It's stretched to left and right, so that means the a squared value has to go underneath the x squared term. So we have 4 and a 3. So what I have for you guys on the formative is I basically put in 4 of this style of problem. When you go through this thing, make sure that you plot so you understand which direction things start shifting and going through. As we get into the actual shifting of these things next week, the writing of the equations can be a little bit more complicated, so we might take a little time here to reemphasize a little bit of the distances parts, but overall, you should wind up just seeing a little patterns with way certain things are set up. So good luck. I hope that you guys have a great weekend, and if you have any questions, like I always say, just shoot me an email, and we'll get through this. Thanks, guys. Take it easy.